Hey, I'm Michael Kammer, and I want to tell you a little bit about what a flame is. A flame is an awesome phenomenon that we can learn so much about by studying. So where do we start? Well, let's start with the chemical reaction. Atoms, the smallest bits of matter that everything in the world is made up of, are held together by bonds. These bonds can be imagined like a rubber band. The bonds will hold two atoms together, and if you try and pull them apart, the bond will force them back together. But if you force them apart too hard, the bond will break. So just like our rubber band broke when shooting across the room, so too do chemical bonds break and release a ton of energy. Now if you notice, this bond didn't break on its own. We had to put energy into it. This is why we have to strike a match or do something else to start the fire. So now we have all these atoms that have broken their bonds bouncing around. What are they going to do? Atoms like to form bonds so that they have a full shell of electrons. So these atoms are bouncing around and they're going to bond with the easiest thing that they can bond to. Here we have the full reaction written out. It's known as a combustion reaction because we're combusting hydrocarbons, which are carbon-hydrogen bonds, and oxygen, and turning them into carbon dioxide and water. So in the flame we have a chemical reaction that's turning carbon and hydrogen and oxygen into carbon dioxide, water, and energy. So where does the light come from? Well, in an atom we have a nucleus and electrons orbit that nucleus. But when an electron gets excited because it's received some energy, it jumps into a more energized orbit, the same way that we jump off the couch when we get really excited. But electrons are really lazy, so they don't like to stay in that excited orbit, so they crash back down to the lower orbit. The same way that when we're tired, we crash back down on the couch. When an electron crashes from a higher orbit to a lower orbit, it gives off light, in what's known as the photoelectric effect. This is what Albert Einstein won the Nobel Prize for discovering. So we figured out the light, but what about the heat and the shape? Well, what we feel as temperature is really just atoms jiggling around. Things that have a low temperature are jiggling really slowly, and things that have a high temperature are jiggling really, really quickly. So in our reaction, when all these bonds broke and all this energy was released, all the atoms started jiggling a lot and they got really hot. Also, as we see in the chemical reaction, we went from a solid, the wax, and a gas, the oxygen, to having a gas, the carbon dioxide, and water. But this isn't just normal water. This is water that's been heated up a lot, so it's steam. So we have a lot more gas coming out than went in. So all this gas wants to expand, the same way that when you blow up a balloon, the balloon wants to expand. So this gas wants to expand in all directions, but we've forgotten about gravity. Hot gases rise and cold gases sink. We know this by looking at a hot air balloon. We heat up the air on the inside of the balloon and the balloon rises. So as the gas produced by the flame expands, it also rises. So it goes out and then up. And that's what gives rise to the really cool shape that a flame has. So there you have it. A flame is produced by a chemical reaction that gives off a lot of light and heat and gas that likes to expand. Until next time, I'm a physicist in progress, Michael Kammer.